Hey y'all, this is a quick part 2 of section 1.1, Propositional Logic. In part 1, this is part 2. In part 1, we learned about propositions. These are true or false statements. We also learned about proposition variables. Basically, it's like P, Q, R, S. Like this is what people use, and like P is equal to, and you write your proposition in right here. You're right here, and just basically, these variables represent these propositions, and you use these variables when you're talking about operators like your not operator, your and, ors operators. When this operator here connects two different propositions, it's called a connective. So in part 1, we learned about the not operator. So like not, like example, not P, or not Q. We learned about the and, the or. These are connectives like P and Q, or P or. And we learned about the if P then Q. So like example, P Q is equal to if P then Q. And we also did we're learning about number 5 today, and very quickly, and we did also truth tables of each of these operators, and truth tables let us easily say we have P and Q right here, and P is true and Q is false. We can easily go to our truth tables, which I'll show in a second, and we can decide that is false and that is like P or Q, and if this is true and this is false, then it's true. So it's pretty easy to do that. So here is you can like pause it for a second and kind of screenshot that. These are a bunch of truth tables for the and the or, if then, exclusive or, and we're learning this truth table today. Like I said, like P, Zach has a dog, Q, Kyler has a dog. If this is true and this is false, and the teacher asks what is the truth value of P and Q, you go to your and, since you're using and right here, you go to your and table. Since the first one is true, the second one is false, then the statement would be false. So it says what's the truth table of P and Q is false. Super easy. So the biconditional operator is P if and only if Q. So, or like R if and only if S, or S if and only if R. So this little like double arrow line is if and only if. So like P if and only if. So say P is I have a dog, and Q is equal to I have a cat, then PQ is equal to I have a dog if and only if I have a cat. So basically on the truth table, it's true when P and Q are either true or false. So I can show you that very easily. Biconditional truth table right there. True, it's true. See how it's true when they're the same, it's true. When it's opposite, it's false. So basically that. You can screenshot that one more time if you didn't get a chance last time. There's one more thing in this section, precedence of operators. So the highest precedent is this not operator, and then and, or, if then, and then biconditional. So say you have a statement like not P and not Q, if like then not P. So say P is equal to Zach has a dog, and Q is equal to Kyler has a dog. So say I'm using this statement, I would first, since the precedent is like these knots, you would do Zach not P is equal to Zach does not have a dog, or you can say it is not the case that Zach has a dog, and then not Q is equal to Kyler does not have a dog. And then since you would use the and operators first before you go to this part because it's lower, so not P and not Q is equal to this and this. Zach does not have a dog and Kyler does not have a dog. And then you would basically, for this whole statement here, you would write if Zach does not have a dog and Kyler does not have a dog, then Zach does not have a dog. So it doesn't really make sense, but like I'm just showing you kind of the precedence of the operators. So this whole thing would be equal to this, and all I did was did the nots first, and then I did the ands, and then I did the the if, since that comes last, and this is last. So that's kind of how that works. So if you have any questions, leave them in the comments. Like, share, and subscribe, please.